My name is Mark Selby, Chair and CEO of Canada Nickel. Very happy to be here today at SGS Lakefield, where we're running a pilot plant on the Crawford Nickel Sulfide project flow sheet. The purpose of running this pilot plant is to generate hundreds of kilos of concentrate that we can use with potential customers in the EV industry, as well as potential customers in the stainless steel industry. We're very, very pleased with how this pilot plant has run. We've now run our process flow sheet in 3 separate labs at XPS and Chromium, and now at SGS, which clearly demonstrates how robust this flow sheet is. We're very happy with how quickly the flow sheet ramps up, how stable the flow sheet is once it's ramped up, and I'll now turn it over to Arthur Stockreef, who will walk you through the various steps that we're doing in the pilot plant here today.
Hi, my name is Arthur Stockreef. I'm the Manager of Process Engineering and Geometallurgy at Canada Nickel Company. I'm here at SGS Lakefield today, supporting the execution of the pilot plant. Today I'm going to walk you through each of the unit processes used in our flow sheet. So the first step in the flow sheet is to do your primary crushing and initial grinding. We grind our ore to a primary grind size of 180 microns in the pilot plant, and this is done using a rod mill and a ball mill, which is closed using a screen. After the primary grinding, the first step is to do a deslime of the ground ore. So this removes the ultrafine slimes which affect flotation performance, and so it just removes them from the flotation circuit. The underflow from the cyclone is processed using a first rougher flotation stage, which is about recovery and maximizing recovery in the coarse flotation circuit. The concentrate out of this rougher flotation stage is then cleaned using an initial first cleaning stage. For this pilot plant exercise, this is where we're stopping and we're collecting this intermediate concentrate for further processing. The further processing will be done in the lab, as this provides better control over the process. So the tailings from the coarse rougher and coarse first cleaner flotation cell are combined together and then regrind to a target grind size of 100 microns. This is done using a smaller ball mill. And after grinding, the product from this mill is then passed through another deslime cyclone. So the key here is that after you're doing a grinding stage, it's important to have a deslime to remove the ultrafines. In the fine flotation circuit, we use the exact same setup as in the coarse circuit with a fine rougher stage and a fine first cleaner stage. So again, we're producing an intermediate concentrate here, which will then be further upgraded on the lab. The tailings from the fine flotation circuit are then fed into what we call our magnetic cleaning circuit. The first stage here is a rougher magnetic separation stage where we drop out as much of the gangue as we can so that we can minimize the amount of mass we're treating. The concentrate off of this rougher magnetic separator, which is about 2000 Gauss, is then ground to a grind size of 63 microns and then treated through magnetic cleaning stages, which are at 1500 Gauss. Similar to the flotation circuit, we're stopping short to produce an intermediate concentrate, and then in the next stage of piloting, we'll upgrade this to a final concentrate.
As you can see from Arthur's walkthrough of the flow sheet, we're very happy with how the flow sheet has performed. We've been able to hit the target volumes and specifications for the concentrates that we're going to produce. We've been able to confirm that these tailings dewater very rapidly, so much so in fact that the water that comes off of these tailings is clean enough to be able to be discharged directly into the local sewer system without having to be treated first, which again confirms just how benign some of our tailings and waste rock are going to be. And then finally, one of the key benefits of this pilot plant, we've been able to demonstrate our new magnetic circuit configuration, where we've increased the intensity of the magnets, and it has led to dramatic increases in both the iron recoveries and chrome recoveries in the flow sheet.